Hi, welcome to Unit 1. We start with the real number system. Hopefully you've already done the guided notes and glued them in. Now you have the practice sheet in front of you. I repeat, again, do some of the practice sheet before you watch this video so that you're using it to check your work, not do your work. Because if you're not doing your work, you're not learning and you're not going to be able to pass the mastery check. Alright, so name all sets of numbers to which each real number begins. Let's go ahead and jot them down. Right, we have real, and we have irrational, and we have, what did we decide to use? Q for rational, and then we have Z for integer, W for whole, and N for natural. Just so that we'll have them in case we need them. Alright, all sets of numbers to which each real number belongs. I'm going to work all the odd numbers. And again, you work the odd numbers first, and then go back and watch the video to check to see if you're right. If you also want to work some of the even numbers, great, but you don't have to. You don't even have to work all the odd numbers. Just work enough to prove you can do it. Prove to yourself. Just work enough you can prove to yourself you can do it, so that you know you can pass the mastery check. Alright, 12. It is all, right? It is natural, whole, integer, rational, and real. It is all of them. 3.18 is not natural or whole or an integer, but it is real and rational. We have a fraction, so just like a decimal, I'm only supposed to be working the odd, my bad. Real and rational. 3 is a fraction, so real and rational. 5 is the square root of 48. The square root of 48 does not make a pretty number, so it's actually irrational and real. 7 we already did. 9 is the square root of 3, and the square root of 3 is another one that is real but irrational. Square root of negative 12. 12 isn't a perfect square. Like 3, it's not a perfect square. 25 is a perfect square. So this would actually, the square root of 25 is 5. Because 5 times 5 is 25. 5 squared is 25. So this would actually be 5, which would be all the things. But because these are not perfect squares, they are not all the things. Irrational and real. Alright, and then scroll up. Place the letter of each value in its location in the real number system. Basically, they want you to recognize that, like, if you have a natural number, it fits into all the other categories. Natural is also whole, integer, rational, and real. Right? They want you to recognize that, like Russian dolls, they fit into each category. Right? So let's just do some random ones. A, 2.125. It's a decimal. So A is not natural or whole or an integer, but it is rational and it is real. Being interrupted.
Yeah, the office phone.
Yep, no problem. 0 is not natural, but it is whole. So B, B, B. And then pi, we talked about pi. It's a non-repeating, never-ending decimal, so it's irrational. Let's pick another interesting one. J is the square root, -7, negative square root, so that's -7. So it's not natural, or whole, but it is an integer, which means it's rational. So basically just go through and see which categories each of these falls in. Some of them fall in multiple categories, and that's completely okay. Alright, questions. Give an example of a whole number that is not a natural number. 0. And this one you can copy because 0 is the only whole number that's not a natural number. It's the only option. 2. Give an example of a rational number that is not a whole number. Alright, so anything with a negative or a decimal or a fraction is rational but not whole. So anything, 1/2 or -5. Give an example of a real number that is irrational. Irrational are never-ending, non-repeating decimals. So pi is a perfect example, or any of those other examples we talked about. Are integers always, sometimes, or never whole numbers? Integers are sometimes whole numbers, right? They're not always whole numbers, because integers include negative numbers, and negative numbers aren't whole numbers. Integers are not never whole numbers, because integers also include 1, 2, 3, 4, 5, and whole numbers include 1, 2, 3, 4, 5. So sometimes. Are natural numbers always, sometimes, or never rational numbers? Natural numbers are your finger counting numbers that do not include 0. So they are always rational numbers, right? It fits into that category. Natural numbers is always a rational number. It fits into that category. So always. And are irrational numbers always, sometimes, or never rational numbers? You cannot be both irrational and rational. They're opposites. So never. They are never the same. Never the same. Alright, feel free to watch the extra videos I've attached if you need more help, and make sure to do your mastery checks on the back wall. Thank you.